Examining the effects of anticipatory robot assistance on human decision-making. Robots have previously been designed to perceive a partner's goal and perform anticipatory actions to assist in service of accomplishing that goal. Collaborations designed in this way are beneficial as they can speed up the overall exchange and engender fluid interactions. As anticipatory actions are necessarily performed prior to the realization of a goal, these actions have the potential to affect the user's own decision-making process. This potential is what we investigate in this paper. Imagine you walk into a robot-operated smoothie bar craving a banana smoothie. By analyzing your eye movements, the robot barista anticipates your preference and prepares your drink before you make a formal order. You watch as the robot reaches for strawberries. Should you correct the robot and ask for the smoothie you initially desired, or acquiesce to this undesired alteration? Either way, your decision is now a function of the robot's anticipatory action. To explore how anticipatory actions affect user decision-making, we designed a study where participants make candy selections. A robot forecasts and acts in anticipation of the unarticulated candy choice. The participant then selects their desired candy. How often the participant's articulated candy selection matches the unarticulated forecast candy allows us to determine whether the robot's anticipation affected the participant's candy choice. To start, the participant sits in front of 3 bins, each containing a unique and unfamiliar candy. Corresponding to these bins are 3 buttons that the participant can use to signal their preferred bin. Nestled discreetly in front of these buttons is a Tobii Pro eye tracker. Behind these bins sits a Canova Miko robot arm that can autonomously pick up and deliver a bin to the participant when prompted. Participants first gaze at the bins, deciding which to choose. The robot uses the eye gaze during this period to estimate the participant's final decision. The robot then randomly selects to make either no movement, the control, a collaborative action, a movement toward the participant's estimated decision, or an adversarial action, a movement away from the participant's estimated decision used to model the worst-case prediction mistakes. At this point, the buttons illuminate and the participant selects their bin. Finally, the robot picks up and hands the requested bin to the participant. We introduce a novel experimental framework to study unarticulated intent and the bidirectional relationship between participants and robots during anticipatory interactions. Our gaze-based intent predictor is able to predict bin selection significantly more often than chance. We see people are less likely to accept the robot's bin suggestions in adversarial than collaborative conditions, but unarticulated goal recognition is difficult and requires continued improvements. We saw qualitative differences in participant sentiments towards the robot between collaborative and adversarial conditions, indicating that there is a perceptible difference between these scenarios. We suggest this bidirectional relationship be studied further and accounted for when developing anticipatory interactions. Thank you so much for your time. For more details, please read our paper.